Alright, this is my podcast for myself when I'm a junior, and I better be a junior taking organic chemistry. And in hopes that I am able to reteach myself these things, these basic parts of these things. And, gosh, I really hope I remember to put this on a flash drive and take it with me or something, because I'll probably forget. Well, unless it's uploaded to YouTube anyway. So let's jump right in. Alkane, alkene, and alkyne. I'll apologize in advance right now. I'm not feeling my best, so might get a little sick feeling now and again. And I'll pause and have to look at my notes, so I'll apologize in advance for that. Now, for alkanes, for all of these really, it's real simple to remember since, well, here we have A, and that comes first in the alphabet. And in this here is the alkane, and it only has one line for each, and one there, 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 and one there. And by line I mean bonds. There's no double or triple like over here with these, like here's a triple right here. There's none of that. It's just one at a time. Now alkene, E comes second in the alphabet, and I don't literally mean second. I mean, out of all these vowels we got here, E comes in second, so that would mean 2, which is right here. There's a good example of it right here. And 2 meaning for double bonds, because this one here has double bonds. And if you at all understanding me. And then we have ein, alkyne, which of all these, this vowel comes in third in the alphabet, and this is that example right here. See, there's triple bond right here, right there. So that should be simple enough to remember which one goes to which. I'm sure you don't really need to go over that, but you never know. It's quite a ways away. Now let's go a little more into alkanes. These are all alkane. Let's start with this one right here. When numbering these things, it's always a smart idea, and really the way you're supposed to do it, to start numbering and make the longest chain. What that means is you start at one end, let's start over here, and end at one of these ends. Now you have to count each joint on its own, meaning here's 1, there's 2, there's 3, there's 4, 5, 6, and 7, just cause. Now I could have gone 1, 2, 3. Let's write this in a different color. Could have gone 1, 2, 3, 4, but that would only have left me with 4 rather than 7. So this can't be my longest chain. And we also could have gone 1, 2, 3, 4, 5, 6, and then 7 up here, which would have been fine. That would not have been a deal, something to worry about. But I just chose this one just because I wanted to. They're all just the same. Now over here, now let's go back to this one now. Let's erase some of this stuff. So complicated. Alright, nope, there we go. Now, that's just numbering, so we still have something to do with these two other lines coming off of these, and what we call these are methyl groups, because there's only one. Here's the carbon that they attach to, and that carbon is attached to the longest chain. So, and since there's only one other carbon right here, making this bond here. So, one carbon, and that's equal to methyl, the prefix meth. And you're a junior, so you're probably giggling right now, so stop it. And it's the same thing up here, one bond, so M for meth. And then when naming this, let's see here, you start with how many you have, so that's 7, so that your ending is going to be in sept, ane, sorry about that, And how I know it's septane is because there's 7 in the longest chain, starting here to here, 7, so that's where sept comes from. And the ane meaning coming from here, so this goes here, and sept means 7, this number here, so septane. But we still have these two methyl groups, so you'll have meth, and since it's not part, it's a part branching off of the main chain, you'll add the YL, meaning methyl, meaning it's attached to the carbons on the longest chain. And then you specify where exactly on the chain they are. So since they're both the same, and also this another thing here, there's 2 of them, so I don't need to write methyl twice. So instead I'll just go ahead and put dimethyl, di indicating 2. And let's see, you have one methyl group coming off the 3 and one coming off the 6. So it's going to be 3, 6 dimethyl septane. Alright. And over here on this one, we do the same thing. Start counting 1, 2, 3, 4, 5, 6, 7. And for most of these alkanes, it'll be really easy. You'll be able to look at it and determine pretty much where the longest chain will be. Maybe you might have to count now and again, but it's pretty simple with these. So 7 again, so you know it's going to be septane. And here you have carbon, 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 and it's just one methyl group coming off of each. So, and there's 3 of them, so you can put trimethyl. If I could fit it in there. And then, let's see, they're going to come off the 3, the 4, and the 5. So you're going to have 3, 4, 5 trimethyl septane. Easy enough, right? Alright. Now for this over here, this big thing here, we're going to name this differently. Mostly because you can see that it's not lines like these up here. This one's going to be different. Well, first off, you have to determine what shape it is. You can clearly see that it's a ring shape. So it's because it has ring, because it's a ring, you automatically know that it's going to have cyclo in it. So cyclo, and then you count how many carbon bonds there are. So 1, 2, 3, 4, 5, 6. So cyclohexane, hexane is what we're going to use. Alright. And now you still have these over here, this and this. This we've established is a methyl bond, but this is a, unethyl bond. So E for ethyl. Now, when naming these things, you want to go in a way that'll catch these bonds in an early number. So let's say we start here at 1. We can go either clockwise or counterclockwise. Now the way we want to remember is that these right here get numbered with the lowest possible number. So if we go this way, start 2 over here, on this one over here we'll go 2, 3, 4, 5, 6, and they would have 5 and 6. But if we number it the other way, let's see, whoops, what's happening? Oh, alright, sorry about that. Had some computer problems, so that might be something else we may have to deal with later. So just keep with me. Now we already established that what we're looking at right here is gonna be a hexane, not just any kind of hexane. Let's see, let's write it over here. Cyclohexane. Excuse the handwriting. Now, like I was saying, this will be an ethyl group, and this will be a methyl group. Now, as for numbering, I told you let's start over here at 1, and we're going to go clockwise or counterclockwise. We're going to prefer to do it in a way that'll give the ethyl and methyl groups the lowest possible number. So clearly you could see that we're going to go counterclockwise, giving this 2 here, 3, and so on. So that's not really, doesn't really matter. And now we know where the ethyl and methyl group are, but we're not just going to put 2, well, we are, but when naming this, it's always essential. It's possibly the most important and absolute rule in organic chemistry is you name it alphabetically. Something simple like that. So we're going to start at 2, and then 3, ethyl, methyl, cyclohexane. That's the molecule here. Or if you prefer, 2 ethyl, 3 methyl cyclohexane. That is also a good way to indicate which one goes to which, when, where. But yeah, it's pretty easy for now. And yeah, but always remember, give these the lowest possible numbers here, and to always name in alphabetical. So you know, E comes before M in the alphabet. And that if it's a ring, such as it is here, a closed ring, it's gonna have the prefix cyclo, which I misspelled it here. Cyclo. No, I didn't. I'm sorry. I'm looking at this wrong. Alright, we'll have cyclo and then hexene. Hex meaning 6, the number of carbons are in this ring, and ane because they are all single bonds, single bonded carbons.